Hello and welcome to this next video, which is looking at graphs and intercepts. We're learning goal for this one is still that you'll be able to understand linear relations, and after this you want to be able to graph a function using just the axis intercepts alone. Okay, so there are so many different ways to view a function. So you've got the algebraic form, which was to be y equals maybe 7x minus 5. Or you can view them as table of values is another way you can do it. So negative 2, negative 1, 0, 1, etc. Maybe 5, 4, 3, 2, something like that. You can also view them just a set of ordered pairs. So that first one would be negative 2, 5, negative 1, 4, etc. Okay, so that's one way to do it, or you can graph the thing, okay, and it looks maybe looks like that, x and y, okay. So there's lots of different ways to view a function, and in the same way, there's a lot of different ways to sort of draw and sketch and come about with a representation of one as well, okay. So in the last time we looked at just creating a table of values and plotting those points, and so we're going to look at just using the intercepts. So remember that the y-intercept is that x equals 0, and you find it by substituting x equals 0 into the function. Okay, so we've got this function here. So this is in the form 2x plus 4y equals 10. So we substitute, so we say let x equals 0. Therefore we have 2 times 0 plus 4y equals 10. And so 4y equals 10, y equals 10 over 4, which is 5 over 2. 2.5. So our y-intercept here is going to be the point 0, 5 over 2. Okay. Now the x-intercept is at y equals 0, and we find it by substituting y equals 0 into the function. So we've got our function 2x plus 4y equals 10. We say let y equals 0. Therefore got 2x equals 10 and x equals 5, and so that means this point here is at 5, 0. Okay, so that's how we find our intercepts. We can find them very quickly by substituting our zeros into the equation itself and then solving it. Okay. Now there are some special linear functions we need to be able to consider. So there is a vertical one, which is simply in the form x equals b, so x where b is just some constant. Okay, it doesn't have to be an integer, it can just be any number at all. Okay, and so that ends up like this. So for every point x is equal to 4, so y is equal to every possible other option, but x is always going to be equal to 4, and so we end up with a vertical line like this. Okay. We also have horizontal linear functions where y is just equal to c, which again is just some constant. Okay, remember c is the letter that we also use for our y-intercept, and so that's going to be our y-intercept for this one. Y equals negative 2, there's negative 2. Our y-intercept at 0, negative 2. But in these horizontal ones, every x value is represented, but y is only ever going to be negative 2, or some constant. We also have functions that pass through the origin. They are just at the form y equals mx. So they still have a plus c on the end, but it's plus 0. Okay, so you don't bother writing it. So they always have these forms. So y equals x, we've got y equals 2x here, y equals negative 3x, and they're all passing through the origin. Okay, through 0, 0. I hope you can see why that is, because if we have y equals 2x, and if we let x equal 0, therefore y is equal to 0. Okay, so no matter which one we feed in, we're always going to get 0 back. Okay, alright, let's have a look at some worked examples. So we're going to sketch the function 3x minus 2y equals 6 by first finding the intercepts. So let's go first. We're going to find the y-intercept. Okay, and we'll do that by letting x equals 0. Therefore we have 3 times 0 minus 2y equals 6. So negative 2y equals 6. Y equals negative 3. Okay, So I've just skipped a couple of steps there, but you should be well versed in your algebra of solving simple linear equations like that by now. So we know that our y-intercept is therefore at 0, -3. So x is 0, y is -3. Okay, so there's our first point down there. Now let's find our x-intercept. Remember that is where we let y equal 0. So therefore we now have 3x minus 2 times 0 equals 6. So we have 3x is equal to 6 and x is equal to 2. Therefore our x-intercept will be at 2, 0, which is here. And so once we've got those 2 points, we sort of trust ourselves to say, okay, so got that right, there's my line. Okay, so that's how you find a function by using the intercepts. If you've been given the equation like that, you substitute x equals 0 first, then y equals 0, get those 2 points, plot them. Okay, you should probably label it at the end too. So this is 3x minus 2y equals 6. Okay, let's sketch the following function. So y equals 4. So remember, that's one of our special functions, and so this is going to be a horizontal. And remember, it's horizontal such that y is always going to equal to 4. So 1, 2, 3, 4. And so we're just going to always be going this way. And so this one is y is equal to 4. Okay, so quite easy to do those ones. Okay, not a lot of no algebra necessarily. Okay, y equals -2x. So when it's of this form, we know that it passes through the origin. Okay, so to get another point to do a line, you just substitute any other x value. So substitute. Whoa, that just doesn't look right. Anyway, substitute x equals 2 into that. So therefore y equals -2 times 2. So y is equal to -4. So therefore another point on this line is going to be 2, -4. So go across 2 down. This is x is equal to 2 down to y is equal to -4. So here's our other point here, and we know the other one's through the origin. So there is our line. Now, ideally you guys should be using rulers and stuff with yours. I hope you can forgive me for not on this, but those are the different ways that you can use your knowledge of special functions or the intercepts to quickly sketch some graphs. Okay, thank you so much for watching.